Hi and welcome to Unit 2, Topic 3, Video 11. And in this video, we'll be exploring back-to-back box and whisker plots and how they can be used to draw comparisons between data sets. Okay, so here's another contextual example, and this one's a little bit trickier. And there's obviously a purpose for that. I want to show you, first of all, how it doesn't matter about the information. We can always do the maths irrespective of the context. And secondly, how we can use box plots to draw a really nice comparison. Hopefully I don't have enough space on this screen. But here we go. I've got FERT A and FERT B, so let me describe the situation. These are crop yields based on the different types of fertilizers. Now I'm going to be honest, made the data up, okay? So let's say that this is a crop yield and it's measured as a value in kilograms per meter squared based on these fertilizers. So you use fertilizer A, and in one sample, 8 kilograms of the crop was yielded from a meter squared of that crop sown, all that to 13.6. Fertilizer B, similar thing. Now as a mathematician, we don't need to know anything about the agriculture behind this. We don't need to know necessarily where this happened. We'd like to control our variables, of course. So if you tell me that fertilizer A was used on a crop in a tropical climate, and fertilizer B was used in a crop further away from the equator and maybe in a drier or more deserty climate, well, that's going to be a concern for me because I can't really compare this. So I'm hoping that the variables are controlled, like any good scientist, and the only variable that's changed is the type of fertilizer. But I'm being asked just to compare the data and come up with some ideas on what the data is telling us. So let's do that. First of all, this has been done 9 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going to calculate, I'm going to mark our median, upper, lower quartiles, min, max. Okay? So we've got min, max. I've done a quick confirmation and this data is written in order because I don't want to muck around with that at the moment. Now we've got 9 pieces of data, so the 5th piece of data is our median. So there is our median and here is our median. And then I've got the median of my lower bound here is between 9.2 and 9.6. Add them together, divide by 2, or just have a look here and I get lower quartile is 9.4. Our median was 10.6, so I'll put that in brackets as round. 9.6 here. Our lower quartile here is between 7.2 and 7.8. So that's a lower quartile of 7.5. Upper quartile, we're looking at the median of these 4 data points, which is going to be in here. 11 plus 13.2 is 24.2 divided by 1. We have an upper quartile of 12.1. Don't worry too much about the maths. Just make sure you understand how I'm finding those numbers and throw them in a calculator if you need to. And an upper quartile here is between those two because we're looking at the top half. And so 12.2 and 13.7 added together is 25.9. Divided by 2 is 12.95 is our upper quartile here. So there's the information that we need and we can use it to draw our box plots now. So I'm going to do a box plot down here. I'll put a lower boundary scale, hoping it's high enough to be on the screen for you. And on the scale I need to go from 4 to 15.2. So they're my smallest and largest. So I'm actually just going to go from 0 to 20. I'll cut it in half to get my 10. I'll cut it in half again to get my 5. Okay, now mine it's not going to be really super accurate. I'll be as good as I can, but again, you would have graph paper, a ruler, pencil. You're going to be a lot more accurate than me. Okay, so I'm going to start with my fertilizer A. So I'll call this FERT A, and I'll do it along here. So FERT A goes 10. Now I'm going to have a look for the outliers in a minute, although I suspect there are none. Maybe there's 4, but let's just start by sketching it. So it goes 8, then it goes 9.4, then it goes 10.6, then it goes 12.1, and then it goes 13.6. So it's pretty boring and compact. Okay, and in FERT B, it goes 4, and then it goes 7.5, which is lower than that 9.4, so I'm just going to make sure it's clearly lower. And so 4 should be below 5. Okay, median is 9.6. The upper quartile is 12.95. And then my maximum is 15.2, which is here. Now this has quite a big interquartile range, which means that these are probably not outliers. Now my scale's not perfect, but I can see that's already bigger than this, so that's going to be below, it's not going to be below 1.5 times this. I can do the confirmation though. Lower quartile to upper quartile has a difference of 5.45 times by 1.5. We're looking at something closer to 8, and 8 below that's going to be negative. So I'm pretty comfortable there's no outliers, but you could do the official check and do your fences if you need to. The purpose here is to actually talk about and compare our data. So first of all, and these are key words, so I really want you to consider maybe writing some of these words down and making a note. Fertilizer A is more compact and more consistent. I can see that it's squashed in here compared to this one. Okay, now it's all a comparison. I don't know whether it is compact. It could be really spread out, but if this one's more spread out, we can say that fertilizer A is more consistent and more compact. Fertilizer B, on the other hand, is more inconsistent and more spread. Okay, if we want to draw the maths on this, we can compare directly their interquartile range or their ranges. So we can just calculate either of those and go, look, here's why I can say that. Okay, secondly, and this is important, that I've got this match up here. It's just going to help me. Okay, remember I've got 25% of my data in each of these sections, and there and there. Okay, and I've got a match between the median and the lower quartile, almost. Not exactly, but really close. So 50% of the data for fertilizer B is below the median, which is 9.6. 25% of the data is below 9.4 for fertilizer A, and they're pretty similar numbers. So I'm going to make the conclusion that fertilizer A doesn't have the tail at the bottom. It's more consistently at 10 or above, and I can see that by matching, than fertilizer B is. And it's a bit stronger in the upper end. Now it might not look like it up here, but this is just drawn up by these two values. Now this is basically the max, but then it drops off really quickly, and all of a sudden we're below. So it's dragged up, but it drops off really quickly. Now in terms of comparing, I'm going to therefore say that fertilizer A is more consistent and is going to probably give you a higher result on the basis of probability, because we've got that lower quartile median matchup. So we can do a direct comparison between medians to make this claim. Median is always a good measure. Median for fertilizer A is bigger than the median for fertilizer B. And we can also compare lower and upper quartiles as well. And so fertilizer B is better in the upper quartile, but it's not as good in the median or lower quartile. So there's some nice comparisons we can make. Going back to context though, whoever's given us this data is probably looking for a reason why they should stick with fertilizer A or fertilizer B, and which one is going to be better. Now, with fertilizer B, you might get lucky one year and get this amazing crop yield per metre squared. Super, that'd be really good. But you might also get unlucky. And you've got to ask yourself, am I prepared to take the risk? And I would say probably in most cases, no. My recommendation would be fertilizer A is going to give you that consistent, pretty well guaranteed result that's going to fall somewhere in here, and so that allows us to forward plan, to organise finances, and to know what's going to happen. But anyway, there's some comparative box plots. Hope you enjoyed. Thanks. Well, great to have you here, and I hope you all agree that back-to-back box and whisker plots are just like drawing two single box and whisker plots, so not a huge amount of extra work. All the best.